Thank you. Hello, everyone. If you maybe some of the people that sit in the very back, maybe you want to come a bit closer. There's still some room here, because it turns out that this is not super duper big. If you want to get a better experience, it's up to you. Oops. All right, so dependency injection Angular 2. This talk is obviously about dependency injection Angular 2. And so we're really going to focus on that particular part of the framework. Actually, we're even taking a look at the implementation of the DI system without the actual framework itself. You know, and then later on, we're going to take a look at how that thing is used inside the framework. Who has done something or anything with Angular 2 already? There are some people from the Angular Masterclass from today. Awesome. Other than that, anyone here in this room? No one? There's one over there. That's good. Nice. Okay, so yeah, let's just get started. Oh, by the way, we'll have some Q&A afterwards. So if you have questions, just keep them, and then we can, you know, discuss things and talk later. And you can also ask other things about Angular 2 if you want. Right. So yeah, that's me. My name is Pascal. I'm a trainer at ThoughtRam. So we do Angular trainings, also Angular 2 trainings. Actually, we did the very first one today here in Berlin, which we're very excited about. And we also work on the Angular 2 documentation. When I say we, I'm talking about myself and Christoph, who sits over here. So if you want to talk about Angular 2, you can also ask him. You can also recognize him with, he actually wears the same shirt as I do today. So it says ThoughtRam, maybe, you know, it helps recognizing him. But yeah, so that's us, and usually, and this is something that is not related to the talk at all, but when I'm bored, so you can see that I have a soap bubble gun here. So that day I got a package from Amazon with a soap bubble gun and a selfie stick and sunglasses. And then I took that picture, and then the next moment I thought I can take it even further. So what I did was I was running through the office and then shooting with soap bubbles at my colleagues while taking a video of that with a selfie stick. It's pretty cool. I like it. Yeah. But anyways, so that's what you can do if you're bored. I sometimes am. You can. Who's on Twitter? Anyone here on Twitter? A couple of people. So you can find me on Twitter. That's my handle, and this is the official hashtag for this meetup. And once this talk is done, that's basically the tweet that you want to send. Right? So I'm gonna keep that here for a second. All right, let's move on. Let's talk about dependency injection. So who knows what dependency injection is? Who knows what dependency injection is? There are some hands going down again. That's interesting. Cool. All right, so here is basically my whole talk in a single slide. And it says, dependency injection is a $25 term for a 5-cent concept. And it turns out that this is sort of true. And we're going to explore why. So throughout this talk, we're first, well, let's start with this guy here. So this is Vojta. Vojta is a former core member of the Angular core team. And the time this picture was taken, he actually gave a talk on dependency injection Angular 2. Surprise. And this talk is also kind of inspired by his talk. But yeah, so during that talk, he basically said that we can see dependency injection as two different things. So first of all, we can see dependency injection as a design pattern. Totally language agnostic, totally framework agnostic, just dependency injection as a design pattern. And then in addition to that, we can see dependency injection as a framework, as an actual system that is somehow implemented. And I'm going to do that today as well. So we're first going to take a look at dependency injection, what it is, why do we need it, why it's awesome, and then we're going to take a look at how it's implemented in Angular 2. Does that make sense? Okay, cool. All right, so let's start off with DI as a design pattern, or also known as the 5-cent concept. So we start off with this class right here. If you're into, who's a JavaScript developer here or front developer? Some people. Okay. So this could be ES 2015 code. So a class in ES 2015. A class in ES 2015 has a constructor or can have a constructor and some methods on it if needed. And so what we see here is basically just a car class, right? And it has a dependency against something called an engine, because you need an engine in order to construct a car, right? And then you have a dependency against tires. You need tires to create a car. And also some doors, and maybe also some additional stuff. So this particular code right here has 3 dependencies. And there's one problem with this code. And maybe it's super obvious to you. So what we see here is that the constructor of this particular class knows exactly how to create the dependencies in order to create an object for this class, right? So whenever I create a car object, the constructor knows how to create an engine or tires or doors. And that can be quite problematic when it comes to testing, because, I mean, we all write tests, right? Who writes tests here in this room? Okay, almost all of them, that's good. So if we write tests, or actually we write tests, we want to be able to sort of, configure the environment for each test so that when we instantiate a car object, we probably want to mock out all of these dependencies like, engine and doors and tires and whatever else. And it's pretty hard to do that when all of these implementation details are kind of hard-coded right into the constructor. So we need a way to sort of make this more reusable. And yeah, so we can basically do that by doing the following change. It's just that, and maybe you didn't even see it. I can jump back and forth again. So as you can see, all we did is we basically moved the actual creation of those dependencies to the outside world, right? So we moved the responsibility of creating those dependencies to a higher level. And we told the constructor or this particular class that it just needs 3 dependencies. It just turns out to be engine, tires, and doors. In fact, looking at this code, what we see here is just 3 parameters. It can be anything. So we probably also need something that makes sure that the first parameter is an engine and the second one is our tires and the third one are doors. But yeah, all of a sudden we solved the problem. Because now what we can do is this. We can create our car object like that. Right? We just pass in the engine and the tires and the doors. And then it allows us also to do something like that for our unit tests. We can just mock everything when we create such an object. Does that make sense? Awesome, great. Problem solved, and that's basically already dependency injection. That's it. That's dependency injection as a design pattern. To be a bit more specific, this is technically the constructor injection. You can also do setter injection when you set a dependency through some setter method, and there's also interface injection. But whatever, it turns out that we now run into another kind of problem, because now, at the point that we define the dependencies in a way that somehow the outside world is responsible for creating them, well, we are in charge of creating them because we are the outside world, right? So we end up writing a thing like this, which is a main method or something like that. And as you can see, we basically wire everything together now, right? We have to create that engine, we have to create the doors and everything else in order to create a car. So when we have 4 classes, as we do here, that's not a big deal, right? We can totally do that. But usually when we write bigger applications, which you probably also do, then you have even more classes. Like, I don't know, let it be 20 or 25 or whatever. So let's assume we extend this scenario and we say that each dependency gets yet another dependency, maybe a logger or whatever, and we need to pass it to each constructor. Then it probably looks something like that. So now we have to create this new dependency, and then we have to pass it through each or to each other dependency that we create. And this can get quite hairy if you have to do that for I don't know how many classes, right? So we need, or wouldn't it be nice if we would have a system that takes care of that? Yeah. So, and this is basically where DI as a framework comes into play. Excuse me. So, if we take a look at this code, maybe it would be nicer to have something like this instead. If we could just say, let's create an injector which takes care of injecting dependencies. Right? So all we do here is we say, okay, give me an injector, and then, hey, injector, please give me an instance of type car. Right? And then we can work with that. That's a little bit of dream code, but that's sort of where we want to go. And let's take a look first at how that is solved in Angular 1. So in Angular 1, there is this weird mechanism. If we, for those who don't know, what Angular 1 code looks like, we can create a module in Angular 1 like this. So we do angular.module, and then we give it a name and some optional dependencies, module dependencies. And then if we want to create a service, we do that with a constructor function. So this is pretty much the ES5 equivalent of the class that we've seen before. It's just a function, a constructor function. It takes an engine and tires and doors. And then at some point, we register that particular function as an actual service. This is the thing that makes this particular function available to Angular's DI. Okay, but now when we ask for an instance of that service, of the car service that we register right here, how does Angular know that we need to also inject an engine and tires and doors? There has to be something that tells Angular that the first parameter here is an engine, the second one is tires, and the third one is doors. So what basically happens is that Angular kind of calls something on that service constructor function. So it basically calls toString on it, which is a function that you have on every function due to prototypical inheritance. And so basically what it does, it calls toString. That gives you the string representation of that function, and then Angular runs a regex over that function representation and parses out all of the parameters. So in that case, it would be engine, tires, and doors. And those names are also automatically the service names that are being requested. So this code assumes that there's a service engine, there's a service tires, and there's a service doors. Right? And that's also why this code breaks when you push that to production, because when you push that to production, you want to minify your code. And as soon as you minify the code, this is not engine, tires, and doors anymore. Then it's maybe A, B, and C. And that's why you get an error that says, I can't find a provider, or whatever. So that's the magic behind Angular 1's dependency injection. In order to get around this minification issue, there's this feature of annotations. So all we have to do is there are different ways, but one way is to say we define a $inject property on that constructor function, which has an array with all the service names in the order as they're applied as dependencies in the parameters in the constructor. And now we have strings as the information, which are not minified, because they can have useful information. So that's the safety net for Angular. So that's the way we sort of make sure that all of these dependencies are resolved correctly. And then, of course, we can create another service which also just simply asks for our car service with the exact same tools, right? So car has dependencies against tires, engines, and doors, and Angular knows about it due to the annotation information. It's as simple as that. All right, so it turns out to be actually a quite powerful DI system. It works very well, but we have some problems with that, though. So one of them is the internal cache. Services in Angular 1 are always singletons. So maybe we want to solve that. Then there's another sort of issue, which is the namespace collision. So if you create, if you create a service with whatever name, let it be the car service, and then you include a third-party library that also introduces a car service, then the last one wins. So it basically overrides yours. So, you can't have different implementations for the same token. So we need to solve that. And then it's also built right into the framework. There's no way to use that DI system as a standalone thing. Maybe we want to do that as well. And that's where we take DI to the next level. So, dependency injection Angular 2. Before we take a look at some actual code, let's first get some concepts straight. So, what do we need to create a dependency injection systems? What are the kind of entities that we need in order to implement such a thing? So one thing we need, obviously, is an injector, right? An object that injects dependencies into our other objects. And then we have the dependencies itself, right? The objects. We need something that needs to be created. And now the interesting part is, how do we get there? How does the injector know how to create a certain object for a specific type? We need that information somehow. And this is where providers come into play. A provider describes how to create an object. When you ask me for a service car, the provider of it knows how to create an instance of it. Right? It's a sort of recipe, or also an instruction. And it takes a token and it returns the dependency. Right? So that's what we need. And here's what that looks like in code. And so what you see here is, those are low-level APIs. You probably won't use them when you write Angular 2 applications, but you can technically. But this is what is being used under the hood. So what we do here is we import something called injector from the framework. And then we do something like this here. We do resolve and create. So resolve and create is basically a factory function that returns an injector instance for us. And we need to configure that injector. We need to tell it about all of the dependencies that are basically somehow available throughout our application so that it can help us out. We're going to dive into that a little bit deeper in a second. And then once we've created that injector, we can simply ask that injector to give us an instance of type car, for example, and then we get the car. Right? But still, the question remains, how does Angular 2 now know that when we ask for something of type car, that this car has a dependency against an engine and tires and doors? How is that information added to the code when we write Angular 2 code? So it's actually, it's quite simple. We have to add that meta information. This is the exact same constructor that we've seen at the very beginning of the talk. It's just in a very weird, it's aligned very weird because I have to add some more code in a second. But it's the exact same code, just a constructor with 3 parameters. And we're missing the meta information about those parameters. There's nothing that tells Angular that the first parameter is an engine, because it's just a parameter. So how do we add this information? Well, this is where something called decorator comes into play. Who knows decorators? 1, 2, 3 people here. Okay, we can fix that. So you might wonder, what's this weird add inject thing? So we import inject from the framework. An inject is basically, inject is basically the decorator, and a decorator is just a function. And we introduce a decorator by using the add symbol. And now you might wonder, how can we use that when I write JavaScript? Because JavaScript doesn't know about decorators. There's no such a feature, a language feature in JavaScript. And that's right. Because that particular code right here is now actually TypeScript. And TypeScript understands decorators. It translates that code to ES5 in a way that it works. Right? So now we use this decorator and we pass in the information that we need. Right? Each parameter gets a decorator at inject that says, hey, this one is of type engine, and this one is of type doors, and this one is of type tires. But how does this, what does this decorator look like? How is that implemented? So it turns out a decorator is really just a function. This is a very, very simplified implementation of that particular decorator. So you can see it's just a function that returns a function that has access to a target. What is the target? Well, the target is always the class that we are decorating, or the property, or the method, or the parameter, or whatever. So basically what happens, very simplified, behind the scenes is we call inject with engine. That's what happens when we do add inject engine. And that returns a function that has access to the target, so we call it with car. That's what essentially happens behind the scenes. And every decorator that you see sort of does that. It might do some different things. This particular decorator adds a parameters property to the target. So it really depends on the decorator what the decorator does. But after all, each decorator is just a function that has access to its target in a very simplified way. That's the 5-minute version of decorators. So what does that mean if we write that in ES5? Like, how does that translate to ES5? Because we don't have decorators in ES5. We can basically take that code and write it to something like this. So the class is just a constructor function in ES5, because that's what a class is in ES5. There's no magic about it. And then the parameters property we're going to add manually. That's what we usually do through the add inject decorator. And parameters is an array of fields that have some meta information. So you see here that we have that it's an array of arrays. That's just because we can have multiple decorators per parameter. All right, but we just do one decorator per parameter, which is one meta information per field, like per parameter. We're going to see in a second what that looks like when we have more than one decorator. So that's what basically, that's the same code in ES5. It's just that. You just don't have to write that code. The decorator does that for you. It's a better experience. This is actually where people go, yay, I just understood what decorators are. But you don't have to, it's all right. Okay, what about testability? We talked about this thing that we want to be able to swap out dependencies for our unit tests. So now that we know how to create an injector, how can we achieve that? How can we make it possible that we don't want to inject a car object, but rather a mock car object? And this is where we come back to this injector creation kind of thing. So you see here that resolve and create gets a list of classes, right? And then it knows about all of these classes. But it turns out that this list of classes is actually a list of providers. It turns out to be a shorthand syntax, right? And each of these providers basically describes how to create an object for a certain type or token when someone asks for it. It becomes more clear when we take a look at the more verbose syntax. So that's the syntax in longer version. This is the exact same code, just in a different way. So we import something called provide, and provide is a function that returns a provider. And then all we have to do is we can say, okay, when someone asks for something of type car, then use the class car to create an object that needs to be injected somewhere. And same goes for all of the other dependencies. When someone asks for something of type engine, return an instance of class engine. That's what this provider says. And this right here is just the shorthand syntax. As soon as the token matches the recipe use class with the same class, then you can use that shorthand syntax. So those are the tokens. A token can be either a type, which is a class, or a string. And then this here is basically the actual implementation that is being used to create an object. Now you might wonder, why would we want to do that? Why would we ever want to write this code when we can use the shorthand syntax? So that's where the testability kind of thing comes into play, because we can do something like this. We can do provide engine and use class mock engine. It's great. Obviously not really clear. So again, provide engine and use class mock engine. Yeah, getting some thumbs up over there. You know what, you get a sticker. I have some Angular 2 stickers here. You can pick it up after the talk. So basically what that means is you can use the engine type or token throughout your code, but the provider defines how that object is created, right? And this turns out to be very, very powerful because we have other provider instructions. And now you might see some equivalence to Angular 1, maybe. So let's say we have an API endpoint, which is just simply a string, and we want to make that particular value an injectable. We want to be able to somewhere inject this particular endpoint as an injectable. But how do we make this particular string available to the DI system? Because it's a string. Like, you know, we can't just do provide, what is the token? Do we want to create a class to provide that value with a token? You probably don't want to create a class for that value, right? And that's where string tokens basically come into play. So we can totally use strings as tokens if we need them. So we can do this. So we say provide API endpoint. The API endpoint is the token that we use to inject something somewhere. But when someone asks for API endpoint, string API endpoint, then the value api.myapp.com is being injected. Because we say use that particular value. Use value is yet another recipe of creating an object. Does that make sense? Cool. And then later on, in order to inject it, we just use the @inject decorator. It takes a token, which is either a class or a string. And then we can say, yeah, please inject my API endpoint here in my application. But again, the provider defines how that object is being created. Okay, so, but what if we have dependencies that have other dependencies that shouldn't be able to the DI system? So I'll give you a use case. Let's say we have this class right here, which is an exception handler. We want to use that class as a dependency throughout our application. So it's basically somewhere it's going to be used as a dependency itself. But it turns out that this constructor actually asks for a Boolean value. So how do we do this? Like when we add this particular class as a provider to our injector, how do we make sure that this thing called Boolean is being resolved as well? Because Boolean is in that particular case the token. Right? This is just a type annotation, but the type annotation is the exact same information as using @inject in TypeScript. So do we need to do something like provide Boolean and then use value false and then make Boolean always false? Probably not. And that's where using factories basically comes into play. So we can provide factories. We can say we provide exception handler and we use the following factory to create that object. And as you can see, we just do a new exception handler and then we pass in the Boolean value. So now the Boolean value is actually not part of the DI system. There is no such thing that tells Angular what to inject when someone asks for something of type Boolean. And of course, sometimes we have more dependencies on that exception handler maybe. Maybe it needs a dependency, maybe it has a dependency of car or engine or whatever. So how does it get those now? Well, it turns out that factories, of course, can have dependencies itself. So all you have to do is you provide a property deps, which is a list of tokens. Here it is logger. And then all of these tokens are basically also just provided as providers somewhere in your configuration. And then what this means is basically the first parameter, or the first dependency of this factory is of type logger. And this is how Angular knows what this first parameter would be. All right. And then we can have optional dependencies too. And that's where basically the thing comes into play, where you have multiple multiple decorators per parameter. And that's what it looks like. You can say, hey, this particular dependency right here is actually optional. And then it's null. If there's no provider configured for something of type engine, then this dependency or this parameter would be null. And that's actually quite powerful when you think of scenarios like Angular 1, for example, used jQuery. It asks for jQuery if it's somewhere on the global scope, and then uses that one for DOM manipulations. And if jQuery is not there, then it falls back to a JQLite implementation. You can do exactly that with this optional decorator. You can say, hey, do we have a jQuery? Well, if not, then fall back to my own implementation. All right, so that's pretty cool. Still, there is something that we haven't talked about yet. So we solved the following problems. There are no namespace conflicts anymore because now we're basically able to define for each token what implementation is being used, right? It can be used as a standalone thing. What we've seen so far is like the standalone dependency injection code. We haven't built any Angular 2 component yet or anything. This is just standalone DI. So you can totally use that code with other frameworks. Actually, I've seen someone using that with React, so you can totally do that. We have optional dependencies, that's cool. And then we still have this question, what about dependencies itself? Are those singletons or not in Angular 2? Well, it turns out they are. They're still singletons. And now I see a lot of sad faces. But there's a way to get new instances for a service. So dependencies are really just singletons inside their own injector container. So when you create an injector and it has a configuration for a car service and you ask for an instance of that service and you ask for another instance somewhere else, then you will get the exact same instance because you get it from the same injector. It also has its own kind of internal cache. However, we still have this thing called transient dependencies in Angular 2. So in Angular 2, you just don't have a single injector as in Angular 1. You have multiple injectors. Each component in Angular 2 has its own injector, which basically allows you to define providers for each component if you need it. And that gives you always a different instance because each injector has its own dependency instance. So here's what that looks like. So this is the exact same code that we've seen before. We create an injector with a provider engine. So that injector knows how to create something of type engine. And then we create another injector based on that other injector that we created before. So we do resolve and create child. And that one also just gets a list of providers. As you can see, this one also gets a provider for engine. So now we have two injectors. They both know how to create an instance of type engine. But if we ask both injectors for those engines, for an instance of those engines, then you will see that those references will be different. Because the one injector has its own reference of that object that is being created, and the second one has its own reference. And those are different. They're not exactly the same thing. So you can achieve multiple instances of services by creating injector trees using child injectors. And that sounds super weird probably, maybe a bit too much to get this thing working. But it turns out to be super cool because in Angular 2, when you build a component, each component has its own injector. So you don't have to worry about all of that stuff. You just ask for something and you get it. And if you want to override a dependency for a certain component tree of your application, you can totally do that. So let's see what that looks like. Because there's another interesting thing happening. When we have an injector tree that looks something like this, we create an injector with the exact same APIs that we've already seen, resolve and create. And then we give it a list of providers, car, engine, tires, and doors. Nothing new going on here. Based on that injector, we create a child injector. So we do, create and resolve child. And it also gets a list of providers, this time just for car and engine. So now we have two injectors, both with their own configurations. And we create yet another child injector based on that one, with just a provider for car. So now we have a tree of injectors: parent injector, child injector, and grandchild injector. And they have different configurations. Now the big question is, what happens when we ask the grandchild injector for an instance of type car? Where do the dependencies come from? So it turns out that the injector tree in Angular 2 is basically more or less like prototypical inheritance in JavaScript. So when we ask the grandchild injector, hey, give me an instance of type car, car needs an engine and tires and doors to be created, right? So what the injector does, it basically checks, hey, do I have a provider for engine? No, I don't have a provider for engine, because the grandchild injector only has a provider for car, right? So what it does, it basically looks in the parent injector if that one has a provider for engine. If that's the case, then this particular provider is used to get the instance of that dependency. And that goes on and on until you reach the very top of the injector tree. So basically what happens is you get the car from the grandchild injector, you get the engine from the child injector, but you get tires and doors from the parent injector, because only that one knows about those dependencies. Does that make sense? This is super powerful. You're not super excited about it. So when I learned about this, I was more or less like this. But yeah, so, and the exact same tools are basically used in Angular 2 when we build components. And now we're going to take a very quick look at what that looks like. So for those who don't know how to create a component in Angular 2, a component in Angular 2 or an application in Angular 2 looks something like that. Everything is a component, like pretty much everything. So when you start an application, you start with a component, it's your root component, you build up a root component tree. And then a component in Angular 2 is really just an ES 2015 class. There's nothing special about it, just a class. This one even has a constructor with its own property name. And then we need something to tell Angular, hey, this particular class is, by the way, also a component that you have to treat differently somehow. And this is where the component decorator comes into play. And we all know what decorator do now, right? So it's just a function, that adds some metadata to that particular class. A component gets a selector, which is basically the HTML tag that is being used in HTML later on. And it has its own template or its own view, right? So now you can take this app tag and put it somewhere, and that will be your component. And somewhere inside the component there is this view. You don't see it from the outside world. Okay, so now let's say we want to, well, first of all, we need to bootstrap that app, right, in order to run it. So you call a function bootstrap, you pass in the component, and that's how you start your application. That's your first Angular 2 application. That's how you create your first application in Angular 2. There's nothing more you have to do, except for adding the app tag to HTML. Now let's say we want to change this property, name property assignment with getting the value from an actual service. So we need to inject a service somehow, and then we can ask for the value. Well, what we need to do is, first of all, we create that service. And this is the service. Super simple. Just a class. It has its name property and a getName method. That's it. So we somehow need to get an instance of that and then call getName on it. And that's what we want to do. So how do we get this name service or an instance of that service into our component? Well, it turns out that Bootstrap basically takes a second parameter, which is a list of providers. And you could probably think what that is. It's just the same thing that we've seen earlier. You just don't have to call, resolve or create and resolve or something. Angular does that for you. All you have to do is to add the list of providers to that Bootstrap thing. And again, this is the shorthand syntax. You can totally do provide name service and use class foo service or whatever. So adding the provider to the application tells the application what providers we have. And now we still, of course, need to inject it somewhere. And that's what we do here. We just do add inject, and then we give it the token, which is name service, sorry. And then we can use that service. Does that make sense? And as I mentioned earlier, if you use TypeScript, you actually don't even have to use the @inject decorator for that, because in TypeScript, the type annotation is translated to the same metadata as the decorator information from the inject decorator. So what does that mean? We basically can write raw TypeScript code with no Angular machinery at all to get this functionality. This is pure TypeScript. Of course, the component decorator is an implementation detail of the framework. It's a decorator provided by the framework, but it's just a decorator after all, and TypeScript knows what a decorator is, right? So that's it. And now we get this instance here, and we can work with it. And we can basically ask for something of type name service throughout our entire application. We would get the exact same instance always. If we don't want to get the exact same instance, well, then this is where child injectors come into play that we've just seen earlier. So basically, let's say we have a child component, and it also needs a name service, but a different implementation. How do we do that? So as mentioned earlier, every component gets its own injector. Basically, this is what it could look like. Here we have a child component. It, by coincidence, has the exact same logic as the other component, but it's another component. It's a child component that should be used in the root component. So it asks for something of type name service, and if we leave the code as it is, then this name service will be the exact same instance that we also have in the root component, because we know we have just one injector. It knows about this provider, and you get the same instance. But now let's say we want to have a different name service here for this particular component and its entire tree. Then we need to provide a different provider for this particular component. And we do that with the providers property. And the providers property, again, is just a list of providers, the exact same thing that we pass to Bootstrap, the exact same thing that is passed to resolve and create. But here we're a bit more specific. Here we say we provide namespace. Like when someone asks for an instance of type namespace, we want to use the class other name service. Sorry, not namespace. We want to use the class other name service to get an instance of that class. So that basically means the instance that we get in this particular component is not the name service component service anymore. This is the other name service implementation. But you can see the token that we use is exactly the same. But now this instance is available for the entire tree of that component. So whenever you ask for something of type name service somewhere else in child components of that component, then you will get the other name service instance, unless you override it again. So this is basically the facade that you use that is in front of the child injector tree. All right. Oh yeah, there's actually so much more to talk about in dependency injection in Angular 2. We have things like dependency qualifiers, where you can specify how far we want to do a lookup in a dependency tree for dependency, so you can restrict that. We have view providers to restrict from where dependencies can actually be requested. Platform injectors, if we bootstrap multiple applications, then you can use them. And other things, but there's no time for that in this talk. So this is basically all I have. If you are interested in Angular 2 stuff, we have a blog, blog.thoughtram.io. It's basically the most visited resource on Angular 2 stuff. We actually hit the 100,000 mark of readers in the last 30 days. So every 30 days we have over 100,000 readers, which is pretty amazing. So you might want to check out that blog. Or you can just go to Exploring Angular 2, which is basically just a compiled list of all of our Angular 2 articles. Because we also cover Angular 1 articles. If you don't want to learn anything about Angular 1, then just check out that website. That's only Angular 2. And I think that's all I have. Thank you. Any questions? there's a question over there.
Bit of a strange one, maybe. You said there's, for dependency injection, there's two reasons. One, stripping down the application and telling it when to use what. And then when you test stuff, just swapping things against mocks. Why shouldn't I use a module loader to do the same thing?
Well, because the module loader doesn't solve that problem. The module loader loads stuff, but it doesn't inject instances of something into something.
But I could tell the module loader maybe to take the, I don't know, engine mock if somebody requests an engine.
You can totally do that, but then you have the problem of loading a specific module in your file. What if you want to swap out that one? So it's really, I get your point, because that question always comes up, especially if you think of things like AMD, where you get an actual instance of, I don't know, jQuery or whatever. But I think it's important to understand and see the difference between loading code and actually injecting something and creating instances of something. Yeah. So yeah, Angular, in Angular 2. They use a module system as well, right? They use ES 2015 modules, which transpile to whatever you want to transpile it to, System.js or AMD or Common.js. But still, you need the dependency injection system to manage your dependencies. Yeah. Any other questions? By the way, you get a sticker for that if you want. We also have ThoughtRamp bags if anyone is interested. Just ask questions and then we give you some. No more questions? Oh wow, okay, interesting. Well, if you maybe that was, I know it's hard to understand that stuff up front in just, a couple of minutes. So there is an article in this slide deck, and I'm going to share this link to the slide deck. It's actually already up online. But there's an article called Dependency Injection Angular 2 in our blog. You can actually just Google for Dependency Injection Angular 2. This will be the first hit. And then this is basically a write-up of this talk, like with the exact same material, and you can read everything up in that article. And if you have any questions later on, then you can totally ping us on Twitter or write us an email or something. If there are no more questions, then thank you very much.